So the next important topic is magnitude versus duration plot. Magnitude versus duration plot. So in magnitude versus duration plot, which is called under voltage or very short voltage, which is called under voltage, which is called over voltage. So we discussed one by one. So in 1 to 10 percentage of voltage, 1 to 10 percentage. So we will call this a very short interruption, that will lies only in 1 to 3 seconds. So if there is a 1 to 3 minutes event duration, that is called short interruption. If there is a 1 to 3 hours, that is a long interruption. So more than 3 hours, we will call as very long interruption. So below 90 percentage voltages, or we will call as very short under voltages, up to 1 to 3 cycles. Below 90 percentage, up to 1 to 3 minutes duration, we will call short under voltages. So below 90 percentage voltage, 1 to 3 hours, we will call as long under voltages. Above 1 to 3 hours, below 90 percentage voltage, we will call very long under voltages. So normally we know 100% is a normal operating voltages, which is a reference. So above 100, that means exactly above 110 percentage, we will call as very short over voltages. So up to 1 to 3 minutes, we will call short over voltages. 1 to 3 hours long over voltages. 1 to more than 3 hours, we will call as very long over voltages. These are the classification by reference of Boolean. By reference of Boolean, we classified into very short, long and very long. So another important magnitude versus duration plot will be treated just like as. So before 0.5 cycles, of time, we neglect the sags, swells and interruptions. Below 1 minute duration, we will call it a short interruption. The voltage is 1%. Below 1 minute, we will call it a short interruption. So above 3 minutes, we will call long interruption. Above 3 minutes, we will call long interruption. Below 90% of voltage, we will call it a sag or voltage dip. So next one is normal operating voltages. Here also 100%. So above 110%, we can classify it into transient over voltages, temporary over voltages and the over voltages. So these are another diagram for magnitude versus duration plots. If there is a interruption, the interruption will be classified into momentary, temporary, sustained interruption. Momentary, temporary and sustained interruption based on time period. Before 3 seconds momentary, before 1 minute temporary, above 1 minute sustained interruption. So again below 90% is a voltage sags or under voltage, which is called voltage sag. Before 1 minute, we will call as voltage sag. Above 1 minute, we will call as under voltages. So above 110% also, we will classify into transients, swell, over voltages, which is called transients. Before 0.5 cycles, that is a transients. Before 1 minute, we will call as swell. After 1 minute, we will call as over voltages. This is another type of classification. So the transients will be classified into instantaneous transients, momentary transients, temporary transients, under voltage transients. So instantaneous means before 30 cycles, before 0.5 cycles is a transients, before 3 seconds momentary, before 1 minute we will call as temporary. If the voltage is less than 10% with a particular time, that is a 0.5 or 30 cycles or 3 seconds or 1 minute, we will call as interruption. Above 110% we will call as swell. Above swell means before 1 minute, above 110% of voltage, we will call as swell. So after 1 minute, above 110% of voltage, we will call as over voltage. power quality standards. So very important, power quality standards. So Institute of Electrical and Electronic Engineering, that means IEEE, gives certain rules and regulation for power quality issues. So IEEE 644 gives standard procedure for measurement of power, frequency, electric and magnetic fields from AC power lines. IEEE C63.12 recommended practice for electromagnetic compatibility limits. IEEE 518 gives guide for the installation of electrical equipment to minimize electrical noise input to controllers from external source. IEEE 519 gives recommended practice and requirements for harmonic control in electrical power system. IEEE 1100 gives recommended practice for powering and grounding sensitive electronic equipment. IEEE 1159 gives recommended practice for monitoring electric power quality. IEEE 141 gives recommended practice for electric power distribution for industrial plants. IEEE 142 gives recommended practice for grounding of industrial and commercial power system. IEEE 241 gives recommended practice for electric power system in commercial buildings. IEEE 602 gives recommended practice for electrical system in healthcare facilities. IEEE 902 gives guide for maintenance, operation and safety of industrial and commercial power system. IEEE C57.110 recommended practice for establishing transformer capability when supplying non-sinusoidal loads. IEEE P1433 gives power quality definitions. IEEE P1453 voltage flicker. IEEE P1564 voltage sag indices. IEEE standard for general requirements for liquid immersed distribution power and regulating transformer C57. P stands for primary node number, S stands for secondary node number. So in the similar manner of IEEE, we have another association, that is a International Electrotechnical Commission, IEC, that is a Geneva, that is in Switzerland. So IEC bar TR3 61000 2 1 gives electromagnetic compatibility environment. IEC TR3 6100 3 6 gives electromagnetic compatibility limits. IEC 610047 electromagnetic compatibility testing and measurement technique in general studies of harmonics and interharmonics measurement and instrumentation. IEC 61642 industrial AC network and affected by harmonics, application of filter and shunt capacitors. IEC SC 77A low frequency EMC phenomena. IEC TC 77G1 terminology. IEC SC 77A G1 harmonics and other low frequency disturbances. IEC SC 77A WG6 low frequency immunity test. IEC SC 77A WG2 voltage fluctuation and other low frequency disturbances. IEC SC 77A WG8 electromagnetic interferences related to the network frequency. IEC SC 77A WG9 power quality measurement methods. So what are the responsibility of suppliers and users of electric power? What are the responsibility of suppliers and users of electric power? Responsibilities of the utilities are they often perform switching operation in electrical substation to support the loads. These can generate transients, disturbance at levels that will have an impact on electrical equipment. Responsibilities of the power consumers are the some issues that are relevant or energy conservation, harmonic current, injection, power factor and surge current demands.